Hello, everyone. Good morning, good afternoon, and good evening to one and all present here. Dear authors and invited guests, welcome to Technical Session 9E. Myself, Deepika Jain, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, United Kingdom. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday was held in London, and the virtual event is being held through Zoom. That is from 19th to 21st February 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presenters, and each presenter will be given 12 minutes for their presentation and 3 minutes for question and answers. On 10 minutes, I'll raise a gentle reminder. I also request all the participants to stay connected with us till the closing remarks. And if you have any query, you can update to me in the chat box. Just before we start the session, I would like to introduce to our session chairs. Just a minute.
Yes, I'm here. Thank you.
Yes, sir. Just a minute, sir. I would like to introduce to our session chair, Dr. Abdul Wahab Sahabat. He is a lecturer at the Institute of Business and Informatics, Indonesia, and an expert at Commission of the Indonesian Parliament since 2010. He has authored 32 research publications. His expertise spans business, management, and policy analysis, reflecting a strong commitment to research and education. Thank you so much for your presence, sir. Thank you so much.
Okay, you're welcome.
We also have another chair with us, Dr. Firdos Sheikh. He's currently working as an associate professor and DY HOD CSC at Purnima University, Jaipur, India. He has over 15 years of teaching experience in teaching, research and development, and administration in reputed educational institution. He served as an editor of a book and editorial board member of a leading journal. Thank you for your presence, sir. Thank you so much.
Thank you so much. I'm glad to part of this conference.
Thank you, sir. Okay, so we'll move with our first presentation. Who would be presenting a paper on a multi-phase method for computer-aided diagnosis and chest X-rays using convolutional neural networks, transfer learning, and multi-label classification. Yes, Pablo, sir, are you here?
Yes, good morning,
Yes,
everyone.
sir, good morning. Yes, sir, you can share your screen.
Yes, thanks.
Thank you, sir.
One, please. Yeah. 1 minute, please. Sorry.
No problem.
You can see?
Yes, sir, I can see your screen.
Now, yes?
Yes, sir, you can start.
Yeah. Sorry. Good morning. My name is Pablo Salame. I am from Ecuador. I would like to present you my paper titled A Multi-Phase Method for Computer-Aided Diagnosis in Chest X-ray using Convolution Neural Networks, Transfer Learning, and Multi-Label Classification, made myself, Remigio Hurtado, and Rodolfo Borges. In the presentation, uh, we will review the following contents: introduction, problem, and method, results, discussions, conclusions, social implication, and reference. Introduction. Chest radiography has established itself a key tool in medical diagnosis, especially during the COVID-19 pandemic, where the use was fundamental for the identification of radiography patterns associated with SARS-CoV-2 and other intrathoracic complications. The World Health Organization has highlighted its relevance in research limited settings, where it allows rapid access to thorax pathologies. These designs represent a significant clinical and economic burden, particularly in low and middle income countries. For example, in Ecuador, demographic studies have shown specific patterns of incidence according to journey and occupation exposure, underscoring the need for effective strategies for the diagnostic and management of the condition. Chest radiography not only facilitates early detection, but is also key tool for patient follow-up and research planning in health systems, contributing to better clinical management, both acute and chronic pathologies. Um, Artificial intelligence is revolutionary diagnostic image through the use of machine learning, enable to identification of complex patterns with the need to explicit instructions. This helps optimize process such and detections. Segmentation and charter testing of pathology driven the integration of advanced models in medical diagnosis and treatment. In the specific case of chest X-rays, automatic interpretation systems have been developing wide performance compared of the experienced radiologist, significantly improving clinical workflows, decision, make a mass screening of disease. Furthermore, the implication of these models contribute to equitable access, high quality healthcare service, especially benefit regions with limited research and straining to efficiency of healthcare system globally. For these studies, used to dataset being derived CXR. The dataset used for the development of artificial intelligence model chest radiography is composed of open access database contains 15,000 images annotated by 70 experts radiologists, and the image include details annotation with 22 delimited regions and six global labels for identification of suspicious disease, allowing an accurate and structured analysis. This research is great relevance to medical image research and facilitates to training and validation for IA models, driven to developing for advanced tools for automatic diagnostic and improving accuracy and efficiency in the detection thorax pathology. Um, Analyze of X-ray chest artificial intelligence identification of various pulmonary or cardiovascular pathologies, including telaxis, cardiomyopathy, consolidation, interstitial lung disease, and pulmonary opacity. In addition, cardiovascular conditions such as aortic enlargement and calcification are detected, and we will thoracic pathology such as neurothorax, pulmonary nose, pulmonary fibrosis, and pleural effusion. The ensure accessibility and research utility. The data are available in publicly labeled DICOM format and facilitate areas to developing and validation advanced automatic diagnostic models. Next problem. So to research identification, critical problem is a high burden of thoracic disease globally, which represent public health challenges with an important clinical and economic implication. This impact is even more significant in low and middle income countries. We access the advanced diagnostic technology is limited. For example, computer tomography, CT, ultra high effective is expensive and inaccessibility in research controlling settings will chase radiography and more alternative release or interpretation by experts. Radio list the available of which is limited. This highlights the need to develop automatic methods to enable late and efficacious detection of thorax pathology, reducing an exclusive relying on specialists and minimizing delays and clinical decision making. Artificial intelligence emerged a promising solution through implementation of the learning algorithms and optimize the interpretation of chest radiography, research levels accuracy compared of those or experienced or radiolist. Next, I am to develop of the deep learning based system for the automatic decision and classification of pattern in chest radiography using the binary CXR dataset aims to optimize the interpretation of medical image using AI. The approach seeks to improve accuracy and efficiency in the diagnostic of thoracic pathology, reduce dependence on radiologists or research limiting error to design different models of convolutional neural networks, CNNs, will be evaluated and cooperating in order to develop a computer-aided diagnostic (CAD) system that guarantees robust and clinical relevant performance. Method. The proposed method for automated pattern detection and classification in chest radiographs using deep learning and structuring several key phases. In data preparation, coordination, inspection, and removal inconsistent data in performance, followed by statistical analysis and class balancing to reduce reduce biases. In additional data augmentation, technical switch rotation, and translations, and bring across we apply to model generation. During the image, prepare image and reduce and resize image 128 by 128 pixels converts to three channels RGB format normalized to 1-0 range and segmentation into training, no? To 12,000 image for the test and 3,000 image for sets. In the model phase, several convolution neural network architectures implemented and compared, including BGG16, ResNet 15, Inception V3, and EfficientNet V0. Transfer learning exploring initials the models with pretaining weights and imagine nets and adjusted the upper layers be support training be stochastic gradient-based optimization. The training setup includes to binary cross entropy loss fusion and Adam optimization for dynamic learning rate adaptation. Additional callbacks such as model checkpoints are reduce error or plateau and implement to improve model conversion. Finally, the evaluation of the model is performed through key metrics such as ROC curve accuracy, in addition to analysis to evaluation of the loss and accuracy over two epochs. To facilitate to interpretation of the results, performance graphs, and general to visual to effects of the model classification, thorax pathologies. Results and discussions. The evolution of convolution network models include to analyze with BGG, ResNet 15, Inception B3, and Efficient Net B0. Compares the performance in the terms of accuracy and loss. ResNet 15 obtained to highest accuracy, 7.7 to 73.53, 43, indicating better classification capability follow with BGG16 with a similar but slightly lower performance, 0.72707. Efficient net B0 showed uncomparative performance with accuracy of 0.7073, while Inception obtained the lowest accuracy, 0.1714, suggests a lower adaptation to dataset. In term of loss, BGG presented the lowest 0.1873, indicating higher mobile stability, following ResNet 15 0.1934, which confirmed the robust system. Efficient net B0 showed moderate loss 0 0 12 20 20 23. Sorry. With Inception V3 have the highest lossless 0.2473 suggests difficult in generalizations. In terms of comparing analyzer, ResNet 15 stood out the most efficient model with the best balance between accuracy and stability. While BGG16 demonstrate greater stability, albeit with marginally lower accuracy. Efficient net proved be competitive, albeit with a lower performance compared to ResNet 15 and BGG 16 and Inception B3, showed the lowest performance. Probability to its the lower dataset adequacy. For the more detailed evaluation of discrimination available for each model, rock curves, ROC curves, and AUC values will be analyzed. In this picture, show the loss. The loss. Next, so conclusions. Um, in the evaluation and convolution neural networks, CNN models for image classification of the dataset used being Deer CXR dataset, BGG16, RexNext 15, Inception B3, and Efficient Net B0 were analyzed using accuracy and loss and Q metrics. ResNet stood out the most efficient model, achieving the highest accuracy and moderate loss. Suggests a good general, no? BGG16 although with a slightly lower accuracy, present to loss, evidences high stability. Efficient net obtain a comparative performance with accuracy and loss. Although belong ResNet and BGG Inception showed the lowest performance with an accuracy of 0.7040 and highest loss, indication lower adaptation and to the dataset. Overall, ResNet is the position at the best option due to balance to its balance between accuracy and stability. However, the choice of model should consider factors such as dataset usage and computational resource resource available and specific requirements of the task. This study highlights the importance and evidence based selection to improve the effectiveness and medical classification system. Richness is the best choice for the balance between accuracy and stability. Model selection depends on dataset, computation resource, and specific objects. Social implication. The implement an interface artificial intelligence to analyze to chest X-rays, facilitate access to accurate diagnostic and research limited settings, helping to reduce the healthcare gap and communities with a short tapes or radiolist. Diagnostic automation not only decrease the workload on specialists, but also improves efficiency in clinical decision making, enable faster and more effective care, and additional A models can be contribute to prevent and early detection of thorax disease, potentially reduce the mortality and enable their use in mass screening programs for the lung disease. From the economic perspective, the system reduced the need for more expensive studies such as CT scans, this optimizing resources in hospitals and clinics, and promoting a more equitable distribution of medical care. However, to ensure this effective adoption in the essential to address ethical and trust in such an EA. Ensure transparency and fairness in the models to be as in diagnostic, like ways of medical supervision, remains essential to validate results generated by the systems, ensure their reliability and safety in clinical practice. Um, that will be in terms of the works done with Chelsea mentioned in this paper. I don't know if you have any questions.
Yes, sir. Any questions?
Okay, I'm now question clear. Good. Thank you.
Yes, Professor Pablo, right? I am having two questions. Uh, First of all, how you take result for calculating accuracy? What data set you have used to calculate accuracy, and how you can say inception V3, which you told 0.7040 had a lowest accuracy in your previous slides, right? So can you explain how you can say this inception had a lowest accuracy?
Yes, in this study, I can see to model ResNet is the more performance with accuracy. You can see into those pictures and sorry. Yes, you can see these pictures and to ROC curve. The best result is the ResNet 15. BGG 16 is similar accuracy, but don't stability and the best result in the for the student is the ResNet 15. But BGG is other other best solution for the case. And for the study data
Okay,
set,
okay. Tell me, tell me one thing. What tool you have used to calculate accuracy, and what data set you have used? My last question is that.
sorry, I can repeat, please.
What? Yeah.
Repeat, please. I don't. I could hear him.
I mean the tools you use to your research method, I think.
Yes. I tools using Python, program Python. I'm used the models. I use pre-word networks. Use Python
Yeah.
and for the study and use calculate to weight the the data set with a application with a study.
Okay, okay. Thank you, Pablo. Thank you so much.
Thank you. Thank
Thank
you
you
so
so
much.
much. Thank you so much.
Moving on further, we have our next presenter with us who will be presenting the paper on a study to analyze the effects of music and meditation on attention and emotion using EEG technology. Yes, sir.
Hi, can you hear
Yes,
me?
ma'am. You can share your screen.
Okay. Can you see?
Yes, yes, I can.
Okay, I will start my report. Hello everyone. Today I will report on a paper, a study to analyze the effect of music and meditation on attention and emotion use EEG technology. And I'm today's speaker, Mengchen Wu, and I come from the Fengjia University. And here is our outline. I will introduce research background, research questions, and methodology, formulate calculation, experimental result, conclusion, and future research. Music is an indispensable part of daily life, whether during commute, work, or study. Many people enjoy using music to enhance their mood and focus. Research has shown that music not only improves mood, but also influence attention and learning efficiency. Brainwave, which are electrical signals generated by neuronal activity, are categorized into alpha, beta, theta, and delta wave. Music has the ability to modulate these brainwaves, thereby affecting our concentration. This study utilized brainwave experiment to analyze the impact of different types of music on concentration. Given that previous research has shown meditation to enhance focus, we have included a comparison between music and meditation to evaluate participant concentration performance. The experiment explored the RSVP test to induce brainwave activity during focus states. And as shown in the chart above, the experiment began by collecting the resting state brainwave data of the participants. After this step, participants are divided into 3 groups for the brainwave experiments. Group 1, participants first complete the RSVP test, followed by a second RSVP test conducted while listening to classical music. Group 2, participants first complete the RSVP test, followed by a second RSVP test conducted while listening to popular music. And Group 3, participants first engage in a season of deep meditation, followed by the RSVP test. Once the data collected is complete, the brainwave data undergoes pre-processing to remove external noise and classify the brainwave types. The cleaned data is then analyzed to draw conclusions. This study recruited 7 healthy male participants aged between 20 and 24 years for brainwave data measurement and analysis. According to questionnaire research, these participants used to listen to popular music mainly. In this study, all brainwave signals were recorded using the emotive inside EEG device. The placement of EEG device and electrode is illustrated in the diagram on the right. To enhance the stability of the device during wear, conductive gel was applied to the electrode seat and care was taken to ensure a tight fit between the device and the scale. Additionally, participants were instructed to minimize blinking during the measurement process to reduce signal interference. RSVP is a classical experiment method used to investigate rapid vision processing and attention resource allocation. By rapidly present a series of image or text and require participants to identify target item, it assesses their focus and reaction capabilities. In the study, the RSVP paradigm consists of 3 categories: images, numbers, and English words, with each category containing 50 items, including 3 target items. The left image demonstrates an experience of the RSVP experiment used in this study. The target for the images category is guinea pig. The target number is 666, and the target word is dogs. The right images illustrated the framework of the RSVP experiment. A vision cross is displayed for 2000 milliseconds to help participants concentrate on the center of the screen. Upon the disappearance of the vision cross, the first image is shown, with each subsequent image displayed for 200 milliseconds. Each category experiment lasts 120 seconds, and the RSVP is conducted in 3 states, with a 2-minute rest period between each state. And here's a formulation calculation. EEG analysis utilizes alpha wave and beta wave as a primary feature parameter, focusing on evaluating participants' mental attention states during the data processing state. Outliers were filtered based on the range defined by the mean plus or minus 3 standard deviation to enhance the accuracy of the analysis. EEG measurements were conducted using the F3 and F4 electrode position located on the left and right frontal lobes, respectively. In equation 1, alpha AVG represents the average value of the alpha wave, and n is the total number of recorded alpha wave data points. In equation 2, beta AVG presents the average value of beta wave, and n is the total number of recorded beta wave data points. Finally, by combining equation 1 and 2, the R value is calculated using equation 3, which serves as an indicator for evaluating participants' mental attention states. In the equation 4, Russell serves as an indicator of the individual level of arousal, typically associated with attention and alertness, and is evaluated by comparing the ratio of alpha wave to beta wave. In equation 5, valence quantifies the positive or negative nature of emotions, reflecting the degree of pleasure and satisfaction or aversion and discomfort. And this study is divided into 3 groups, with analysis conduct on 2 participants per group. Figure 1 presents the mean alpha value. Figure 2 showing the mean beta value, and Figure 3 illustrates the R value calculated based on the alpha beta ratio. As shown in the figure 1, participants exhibits a relative higher level of relation while listening to popular music, suggesting the popular music effectively promotes emotion relation. The result in Figure 2 indicate that participants share a well-balanced state of relation and activation when listening to classical music, which may enhance learning and concentration. Figure 3 reveals that deep meditation can improve participants' focus to a central extent after the meditation session. And here, the left panel compare pre and post.
Sorry for
Hi.
the interruption, dear presenter. You have 2 minutes left. Can you please conclude as soon as possible?
Okay.
Yeah, all right, thank you.
Okay. This study aims to explore the effect of different music types and deep meditation on focus. So the analysis of EEG data, the result indicate that listening to different types of music and engaging in deep meditation has a significant impact on participant concentration. Popular music has the most prominent effect on emotion relaxation. Classical music enhances brain alertness. Deep meditation proved the most substantial improvement in concentration. The observed change is in arousal and balance demonstrate that meditation promotes both psychological relation and enhance focus. And the future research will focus on examining the impact of different music types, such as RPM music or simple music, and meditation practice, such as mindfulness meditation or guided meditation. Focus and control group is included for comparison or integrating AI to predict trend in emotion and concentration, thereby enhancing the understanding of the relationship between EEG pattern and emotion states. And thanks for listening.
Thank you. Thank you for your presentation. Any questions, sir?
Yes, I would like to ask you about your model. Who you decide your own, or you get from any books or reference?
What? And
The model of your research method. You make your own, or you get from no this before this one.
This one
No, before this one.
before
No. Okay, next.
this one.
Okay. No. Before. Before. Before this one. The model. Before this one. Okay, this one. Okay.
This one.
This is your model, or your own create, or you get from.
You mean the
I mean your reference for this model method.
my reference? And these are RSVs. I watched different reference, and they they is they have their own RSVP experiment, and I just choose that. I think this experiment I can use and try to.
Okay, thank you.
Yes.
Okay.
Meng Chianwu. So
Okay.
you are in your future scope. How you integrated with AI with your research?
I think in the future, if I add a AI, I can protect maybe through the each I can predict the emotion, and just like maybe it's not only popular music and or classical music. So
Okay, Meng.
yes.
Okay, Meng. Just two suggestion from my side. As Abdul Wahab sir said, please include the reference part in your presentation always first, right? So it is missing in your slide. So this is first suggestion. Second, what methodology? Kindly explain in brief in your methodology what tool you have used. So always add in your presentation. So anyone can easily understand what is your methodology and how your methodologies work. So these are two suggestions from my side. Thank you so much. Okay, over to Deepika ma'am. Over to Deepika ma'am.
Thank you. Thank you, sir. Thank you for the presentation. Yes. Okay, we have our next presenter with us who would be presenting a paper on in-band noise reduction from PCG signal using the Buchi wallet-based approach. Yes, sir. Madhvendra Nath, are you here? Okay, he was here and is right now he's not here. All right, we'll move with our next presentation. Just a minute. Do we have the presenter of the paper titled The Role of Chain Management in the Adoption of Smart Card Technology in Public Healthcare Institutions? Sir?
Yes, yes,
Yeah,
good
ma'am.
afternoon.
Yes, ma'am. Sorry. Yeah.
Okay, just bear with me. Let me just showcase my presentation.
Yes, please.
Oh, can you see it? Oh, oh. Put it on the presentation mode. Doesn't allow this thing. Okay, good afternoon. Good afternoon. My name is Lario Malungana from University of South Africa, and my topic is the role of change management in the adoption of smart card technology in public healthcare institution. And we are actually 3 authors. This was part and parcel of my thesis work already. With me, I have Professor Chimbo as a 3rd author, 2nd author, Professor Muti from University of South Africa in the School of Computing. I'll just go through my my agenda, which is introduction, purpose, and objectives, together with literature, theoretical framework, research methodology, findings, and conclusion, as well as questions. In the introduction, let me just pull it a bit so that I can see what I'm taking to. Okay, in the introduction, smart card technology has, it is actually a card which is embedded circuit. It secures the microcontroller or equivalent intelligence and the internal memory, or a single memory of the chip that has any other functionality. You know, with the smart card, you can even use it for any other things besides the besides the healthcare. And then the second one is that the absence of effective change management in the public healthcare institution, healthcare sector, remains to be a challenge in South Africa. We are introducing quite a number of healthcare technologies, and what are my observation, as well as throughout my study that I've been conducting, even when I was doing the data collection, I've discovered that the change management aspect is being left aside, which causes a lot of issues in the implementation of digital technologies or any other smart technologies or any other technologies that are related to public health care. So this study, it's a quantitative study. I've collected my data, as previously said, in Gauteng Hospital in Pretoria, in 4 hospitals, specifically Steve Biko Hospital. The Steve Biko Hospital is it's an academic hospital used by the University of Pretoria, and the Pretoria West Hospital is a district hospital. The Kalafong Hospital is a tertiary hospital, whereas the Tshwane District Hospital, it is a district as per se. Why did I choose all this hospital? I wanted to weigh up options as to measure them in between the 3 three hospitals, the tertiary, the academic, together with the district hospitals. And this data, we have also collected it from the healthcare professionals. And the findings of the study was then that a change management framework would be ideal for this particular study. Oh, just hold on. I can't even move to the next slide. Okay, so this is the smart card, the smart card technology that I'm talking about, which it consists of the computer and any software that can be like with a security built-in features, which requires a lot of authentication as a key as well. And inside and outside, it looks more as like the smart card of any other that you know of. And then the change management side is that I wanted actually in the future, it is quite interesting that we have to now implement the change management into these sectors. I mean, into the public health care, because this is one area in South Africa that has been left out. So it will be key to introduce it will be a key then to introduce change management in any implementation of the technology, because we are having a problem of the literacy, the literacy, whereby you find like they are illiterates and the literates individuals or healthcare professionals with the knowledge of computer. So some do not have this, so we have to address certain aspects in that regard. Oh my, okay. The purpose and the objective of the study, as being said, this was done at Gauteng Department of Health, as now is being announced, you know, as the World Health Organization requires of us to then implement the e-health programs together with the M-Health. So one of those initiatives in South Africa, as we speak now, is the introduction of the information health information system, which is aimed at enhancing the service delivery and the quality of healthcare, more particular in the province, because in Gauteng, we are much more advanced in terms of infrastructure, unlike the rural areas. But the focus now is not into the rural areas per se, but then because the study was done in an urban area, and then the transition is then to now circumvent what is happening, whereby we are using a file system in South Africa, and then the paper-based storage and the retrieval of medical information will have to be advanced using all the innovative ways for delivery of the healthcare. Two objectives of this study is that to ascertain how professional healthcare professionals in South Africa in public hospital view the use of the smart card as a change management as well. So how can we make sure that all these healthcare professionals adopt the use of the smart card, in particular the smart card, however there are any other technologies that now we are introducing them into, and also to determine the role of change management in the adoption of the smart card technology in public healthcare. In this study, what we have actually done, we looked at the well-developed countries. Well-developed countries, we have measured, for an example, your UK, your USA, your Canada. Those are the
sorry to interrupt, Dr. Lario.
Yeah.
This is literature review. Please come to your methodology, what you have implemented, what you have done.
Pardon?
Actually, come to your
Yeah,
work.
Yeah, I'm coming to that, Prof. I've got a reason why, because I cannot rush into the methodology without mentioning the conceptual framework. I don't know. Should I go ahead with your request as you requested? Prof?
Also, yeah, presenter, also please take care of the time schedule as well.
Thank you.
Yeah.
Okay. On our research methodology, it's a quantitative study, and then data was collected at Gauteng, as I've said, and also the participants were female and males from the hospital, whereby we got about 63% of females and 37 of males. And the measurement that we also used, we had education level, whereby we measured the illiteracy and the non-illiterate. And then in the illiteracy part, we looked at the healthcare professionals with from a certificate to a PhD level. And then the education level I've mentioned, the age restriction that we have used, we measured the age from 20, and this study was done during the COVID pandemic. So it was quite a mission to get all the data, because we had to drop off the questions at the facilities. Descriptive analysis as well was used. And what I've done in the research methodology, quantitative positive paradigm was used, cross-sectional study, and targeted population where healthcare professional purposive sampling was used. Structured questionnaires as well was dropped off, like I've said earlier on. The findings of the study indicated that there is no much influence on the implementation of the smart card technology in the healthcare institution. And then we also received a score of 2 signifying disagreement. Communication service quality exhibit low, it actually exhibited low positive and negative skewness. Then system quality and triability exhibit the lowest negative skew as well, as we have mentioned them. So a descriptive statistics was then combined with mean and minimum and skewness values. And also all factors were accepted except one, which was system quality. And then the Cronbach alpha was performed with a value of 9.29. And then we had items of 927. And then, and the hypothesis, all the study then developed a model that I've actually missed the other side. And throughout what we have discovered in my conclusion is that with the level of the leadership, there's a need for the top management or senior management to then support any adoption of technology within the healthcare, in particular now that we are talking about the smart card. And also you have to then have change agents who are going to support all this. And then in the future, the study, we looked at it if it can take the angle of the mixed method approach, because this study was a quantitative, it took the angle of the quantitative approach using the framework of the theoretical of planned behavior, because it will measure the intention of behavior as well. And that's it, that's my references. And yeah, we thank you so much. Hello?
Okay. Dr. Lario.
Yes, Prof.
So my question, have you used a hypothesis in your research?
Yes, we did use the hypothesis, Prof. Hence, I missed that because I think I was getting out of time. Yeah, but we did. We did use the hypothesis, whereby we measured the technological level together with the user levels. Yeah.
Okay. I have no question. I think it's good. Okay, thank you.
Thank you so much, Prof.
So my last question is that.
Yes.
So how you collect your data for implementing effective transformation in public health care of South Africa? So you chosen only hospital specific in South Africa? It is a public or private hospitals?
Oh, yes, hence I'm saying public. In South Africa, what we do, we've got a public sector and the private sector. So the private sector are way too far advanced with their systems. So I've chosen the public sector. The public sector is whereby you do not pay for any services
Okay, thank you
that
so much.
government sponsors. Thank you.
Thank you.
Thank you, Dr. Lario. Thank you. Thank you, everyone.
You are welcome. Thank you so much.
Thank you. So we have our next presenter with us who will be presenting the paper on hybrid machine learning models for driver fatigue detection using EEG and EOG signals. Yes, sir. Are you here?
Yes,
Are you ready with
good
the
afternoon.
presentation, sir?
Now I'm going to share my presentation.
Yes, please. Thank you. Also, do we have the presenter of the paper titled Estimating Forest Carbon Stocks, a review of above ground biomass methods here? Do we have the presenter of this paper here right now? All right. Yes, you can start, sir.
Okay, do you see my presentation?
Yes, sir, I see it.
Okay, so let's begin. Good afternoon, everyone. I'm pleased to be here today presenting our research on hybrid machine learning models for driving fatigue detection. Fatigue is a major cause of road accidents, contributing to between 15% and 30% of crashes worldwide. It impairs concentration, reaction times, and vehicle control significantly increase the risk of accidents. Early detection of driver fatigue is crucial, specifically for preventing accidents and improving road safety. Our study integrates electroencephalography, EEG, and electrooculography, EOG, signals with machine learning techniques to detect early signs of fatigue. In this presentation, we walked through the methodology and the models, use some key findings, and the potential application of our research. So in our project, we develop a hybrid machine learning approach for the fatigue detection. We use a spatial data set with the signals we use to identify early signals of fatigue, and we apply SHAP online for model explainability. The structure or research we follow it Christian methodology, which widely used in machine learning projects. This methodology consists in 6 main phases. Business understanding, we analyzed the impact of fatigue on driving safety. Data understanding, we used the SID-BIG dataset, which contains EEG and EOG signals recorded on the different vigilance conditions. Data preparations, the signals were cleaned, normalized, and transformed in structured features. Modeling, we trained various machine learning models, including random forest, LSTM, gradient boosting, and assembly techniques. And in the evaluation, we measured models performance using root mean square error and explicability techniques. And finally, on the deployment, our model can be integrated into real-time fatigue monitoring systems. The goal was not only build an accurate fatigue detection system, but also ensure its interpretability, making it transparent and relevant for real-world applications. In the dataset for this study, we used the dataset SID-BIG with this is specifically designed for vigilance estimations. This dataset includes EEG signals recorded across five frequency bands: delta, theta, alpha, beta, and gamma. EOG signals with captured blinking frequency and saccharide age movements amplitude. Vigilance labels based on the PERCLO matrix, which measure the percentage of the ALL closed over time. A total of 121 extracted features, 85 EEG based and 36 EOG based. These features are essential for identify cognitive and physiological changes associated with fatigue. We experimented with multiple machine learning models to determine the most effective approach to fatigue detection. The models we tested include random forest, the best performance model in terms of accuracy and reliability, long short-term memory LSTM, a deep learning model designed to capture temporal dependency in each signals, gradient boosting, XGBoost, and light GBM, powerful and simple techniques used for restricted data, hybrid models, random forest. This hybrid model, random forest plus LSTM, combining the strength of both models, like a ensembled technique. To evaluate this model, we use root mean square error. MC has our primary metric. Now, I show the results. The random forest model architecture, the lowest RMIC of 0.0257, making the most effective approach for predictive fatigue. Other models' performance, house below, maybe is important to say that the hybrid is a good one for our results, and the others models performed helpful and show you in the presentation. We also applied chat online to interpret model decision, the most important features, influence, fatigue, detection, where the EEG theta band power is strongly like the cognitive fatigue, EEG delta band power associated with drowsiness and slow wave activity. EOG blinking frequency, higher frequency indicates increased fatigue. EOG saccharide movement amplitude, decreased saccharide sachets, reducing alertness. These findings confirm the physiological signals can really indicate fatigue levels, supporting the development of the real-time monitoring systems. To summarize our research, demonstrate that random forest is the most effective model for dry fatigue detection. By integrating EEG and EOG signals, we successfully identified key physiological market of fatigue. Moving forward, we several potential improvements, enhancing real-time implementation in vehicles, exploring quantum machine learning for improving efficiency, address privacy concerns related to physiological and data monitoring. This advancement could explain the application of our research within transportation benefits such as aviation, healthcare, and autonomous driving. Finally, thank you for your time, your attention. I hope this presentation has provided valuable insights or approach to drive fatigue detection. I will now be happy to take any question.
Thank you. Sir, any questions?
Yes.
Yes, sir.
Zohan, I have one question. You have taken a data set. Why you take a 5 frequency band in seed VIG? Yes.
Yeah. Can you repeat the question, please?
You have taken the seed VIG for 5 frequency band, na? So why you choose the only 5 frequency band?
In the first time in our research, we going to find some data sets, and in the first step in our research, we tried to determine what was the most important features in the datasets. The datasets has a lot of data for try to predict some frequency and signals across some other bands. And we choose it because was the most representativity for try to detect fatigue in the dataset, for try to get the best results for our training models.
Okay, go to slide model performance. Please go to slide on model performance. Okay, so you have calculated random forest 0.0257 and you predict that this is the best model. So how you calculated these all values, and you are saying that this is the best model? How you can say, and what tool you have used to analyze that this is the best model?
Yeah, we train different models with the same data set. We use different techniques to prepare the data sets for the analysis. In the first step, we structured some tests, and when run different models, we got some results that show us that random forest was the best model.
So
We trained it, we used another others
because in your
models.
presentation, John, because in your presentation it is all methodology are missing. Only you have put only the values, but not how to come this value, what methodology you have used. This part is missing in your presentation. Also, one suggestion from my side, also a reference part is missing in your presentation.
Okay. So we used some metrics has accuracy of the models, the performance about um, the um, the use of computational research. You said some we tried to explain with some other tools like graphs of the performance. In that um, in that test, we compared different results, and the best one is showing right now in our presentation. But we used another techniques, and the result was very interesting. But we decided use only MSE has the principal performance
Okay.
to show the results.
So my last question. So how you can improve your accuracy using RF plus LSTM? In your slide, you have shown for improve your accuracy using the RF plus LSTM. So can you explain?
Yes, we used some techniques to try to find some other features in the dataset. and try to get some techniques to try to extract the best performance in that model. Maybe we use some tuning of the data. We use more cafolds, for example. We use another other variables to take the most efficient the results of LSTM.
Okay, thank you so much from my side, and over to Dr. Abdul, sir.
Okay, thank you. I have no questions. Thank you.
Thank you. Thank you, sir.
Thank you very much.
Thank you. Moving on further, we have our presenter with us who will be presenting a paper on N-band noise reduction from PCT signal using Debussy's Wavell's based approach. Yes, sir. Madhvendra Nath. Sir. Hello. Just wait for 5 minutes and
Am I audible to you?
yes, sir, you're audible. Please start sharing your screen.
Ma'am, this is last presentation or we have some more?
Sir, we had one, but the presenter is not available, and if he doesn't come out, this would be the last one.
Okay, thank you.
Yes, sir. Yes, sir. Please start.
Okay.
I'm not able to see your slides yet. Yes, sir. Please start. Do we have the presenter of the paper titled Estimating Forest Carbon Stocks? A review of above ground biomass methods. Do we have the presenter of this paper here, please? Let me know.
Am I audible right now?
Yes, sir, you're audible. Can you please share your presentation, sir? Can you please start?
I have shared the slide. Is it not visible to you all?
Yes, sir.
Hello.
You can start, sir. The presentation is
There is
visible and you're audible as
Is
well.
it visible right now?
Yes, sir.
Okay, thank you, ma'am.
Please start.
Now, greetings to all of you. This is Madhvendra Nath from NIT Patna, India. And my topic of presentation is in-band noise reduction from PCG signal using Debussy's wavelet-based approach. Now, introduction. Basically, the heart sound is acoustic signal, and when it is recorded and taken into the system, that is called a PCG signal, phonocardiogram signal. And there is some need of denoising of this signal before further processing, because some kind of contamination like respiration noises, gastric noise, motion artifacts, etc., get added into the signal. That's why we need to denoise this signal. This is on the screen. You can see this is the basic signal of heart sound, and now the problem statement. Uh, in basically the main focus here is to reduce the in-band noise. In-band noise is what basically in heart sound we consider that there are two major sounds. Those are supposed to be the S1 and S2, first heart sound and second heart sound. And those two major heart sound have frequency range of 20 to 200 hertz. It is supposed to be. So the traditional methods have some limitation in handling those noise effectively. That's why here another method which is based on the Debussy's wavelet based is proposed here. in existing methods, there are some limitations, and those methods were time domain based approaches like Chebyshev IR filters based methods, adaptive noise cancellation. Further, some methods were presented like frequency domain approaches like DFT, STFT, DWT, etc. Those all have some kind of limitation like hard thresholding leads to signal discontinuity. Somewhere parameter optimization is lacking also, and in most of the cases, poor performance in high noise condition. Now, the proposed method it is having this is the wavelet-based denoising approach, having this is basically DV5, which is 5 wavelet having the level 7 of decomposition. This is the proposed method, and its parameter has been optimized also, and soft throttling is used, and in very last, novel parametric performance metric parameter is also introduced, that is a noise area difference, NAD. Now the algorithm steps are like, first of all, the acquisition of the PCA signal. PCA signal is acquired, which is acquired in the lab, and then in the next step, which is wavelet decomposition level, having 7, on some thresholding level also taken. Thereafter, wavelet denoising was implemented, and finally, in the fourth step, the denoise signal has been taken. And very last step, that is step number 5, its denoising performance has been evaluated on the basis of NAD, noise area difference. Now, dataset and pre-processing. Basically, the self-acquired data has been taken in this particular work, in which the 150 subject has been taken, having the age of 18 to 15 years, and all the data has been recorded using the electronic stethoscope. The electronic stethoscope has been placed on the pulmonary portion of the human chest, and in the pre-processing step, some band pass filter having pass band of 20 to 200 hertz has been applied. After implementing this proposed method, uh, on the basis of the evaluation parameter, performance evaluation parameter, that is noise area difference, it was found that our proposed method having the better performance, because higher the NAD value, noise area difference value, indicates better denoising. So this table shows the same thing. Uh, so the Debauche's wavelets based method, which is used here, basically DB5 is used, having level 7 of decomposition, but the optimal denoising for this particular work, and the soft thresholding has been used. Rickshaw have improved the signal reconstruction also. And finally, the novel performance metric parameter like NAD evaluates its denoising performance in better way. Now this graph shows that here in this work, DV5 has been used, and having level 7 of the decomposition, it is shown here that it is having the better performance. This is the absolute value of the hertz sound which is taken, and after that its envelope has been extracted, and this is the an envelope of noisy signal, and this is the envelope of the denoise signal. So after subtraction in both of two, we can get the noise area difference. We have calculated here the noise area difference, and here both the signals, the noisy hertz signal and noisy hertz signal, both have been shown here, and how it is shown that the PC signal has been denoised in better way. So the novel Debauche's wavelet-based approach is basically having the better performance, and using the noise area difference, we have evaluated its performance. We have not used here the SNR or MSC type performance evaluation parameter, because we have considered that the all of the hertz of signal which are, or which is in which I'm taking here, having already noises. So this proposed method performs better. Thank you. Any
Thank you, sir.
question?
Thank you, Madhvendra Nath, for the presentation. Any questions, sir?
So,
Okay,
Madhuri,
I think. Okay,
Am I audible?
okay. Okay. My
Am I
first.
audible, ma'am?
Okay, let me first. Okay, I would like to ask you about
Am I
the
audible,
data you.
ma'am?
Yes, sir, you're
Okay.
audible.
Hello, am I audible?
Yes. Can you hear me?
Hello,
Hello. Okay. My question is the data collection you get.
am I audible, sir?
Right.
Sir, am I audible to you?
Yes, sir, you're audible, sir. You're audible.
Hello. Actually, there is
Sir,
some
you can just
network
change.
issue, so I'm not getting the voice from your side. Sorry.
Hello. Sir, Abdul sir, you want to take it further or ask again?
Yeah, I'll just write my question on chat about the data collection.
Yes, sir.
They came from me.
Yes, yes, sure. He has already left, sir. Maybe because of connectivity issues. Yeah, all right. All right, we have come to the end of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our
Okay, thank
participants
you.
for being a part of this international conference. I hope this session was informative enough. And we, on behalf of the whole team, thank you for the support during this 10th version of the conference and all the previous 9th versions. We will be happy to see you in the 11th version, which is in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer board and the publication will be live within 6 months. So kindly cooperate with the team of ICICT 2025. I also thank our session chairs for chairing this session. Thank you so much, sir. Professor Abdul Wahab Sabat. Thank you so much, sir, for chairing this session. This is from GR Foundation and their partners and the team of ICICT, a token of appreciation to you, sir. Thank you so much. Also, Professor Firdos Sheikh, thank you so much, sir, for chairing the session. It was great to have you both on this platform. Thank you so much.
Okay, you're welcome.
I request all the participants to turn on their cameras for a quick snapshot, please. Just a minute. All right. Thank you, sir. Thank you, everyone. Take care. Bye-bye. Thank you.
Thank you so much.
Thank you.
Thank you so much. Thank you very much.
Thank you.
Thank you so much.
Thank you.
Thank you, everyone.